All right, now we have 8C part 2. Last two examples of all we're going to do with this video. This is a type of problem that you would have on your homework for 8C, and it has to do again with the growth rate, which remember is the birth rate minus the death rate. But the following table, you have a table there. It gives the birth and death rates for 4 countries in 3 different years. Find the net growth rate due to births and deaths in each of the 3 years for country A. Based on these trends, predict how the country's population will change in the next 20 years. All right, so we have country A is what we're dealing with. I'm going to just highlight it so that we can see that the top row is all country A's birth and death rates for the following year. So these are birth rates until you see the column or the table has a column ender, and then the death rates follow that. So we're just going to take 1985's birth rate and death rate and find their difference. So 1985 would be 14.2 is the birth rate, and we're going to subtract 11.4, which is the death rate. And I'm just going to write these all out while I'm doing the problems. 10.7 minus 11.1, because that's 1995's birth rate minus 1995's death rate for this country A. And then 2003, we have 7.6, and we're going to subtract 8.9. All right? And that will give the birth and death rates for the 3 different years. And in the calculator, we'll just do the 14.2 and subtract 11.4. And that is 2.8. So that will be our growth rate, 2.8. And then 10.7 minus 11.1 gives us negative 0.4. That would be the growth rate for 1995. And then 7.6 minus 8.9 is negative 1.3. So as we're looking at this, notice what's happening with the birth rates each of those 3 years in question. So it's a 14.2. and then 10.7, and then 7.6. So it's going down quite a bit for your rate 4, and then 3, and then here we have the death rates going down as well. So 11.4 to 11.1 to 8.9. They're not as staggering as our birth rates in their decline, but we have a 2.8 growth rate. Remember, these are all our growth rates, and then a negative 0.4. So that dropped quite a significant amount. And then it dropped again to negative 1.3. And with it dropping continuously over these 2 time periods, then we would say that the country is going to decrease, right? It says, part of the question asks you, based on these trends, predict how the country's population will change in the next 20 years. So I think the country's population will decrease. All right, the death rates are going down, but here you only have a 0.3 drop and then a 3 drop, 3 point or something close to that. Here we have a drop of about 4 and about 3, give or take a bit. So the country's population will decrease. All right, last example. Use a growth rate of 1.6% to predict the population in 2066 of a country in the year 2006 had a population of 400 million. Use the approximate doubling time formula. So again, we have a growth rate of 1.6%, and the approximate doubling time is 70 divided by that percent, which is 1.6. So 70 divided 1.6 is 43.75, which we'll just say is 44. And that's your time doubling time. And then if it has an initial population of 400, remember that we multiply that by 2 to the little t, and little t is going to be the difference between 2066 and 2006, which is 60 over our doubling time, which we found to be 44. And that will give us an approximate population after 60 years have passed with a growth rate of 1.6%. So 400 times 2 to 60 divided by 44 is 1,029.33. So we'll just round it to 1,029 will be the population. And that's in millions. I probably ought to write an M there. So we know that's how many million people. Started at 44 million. You have pretty good growth rate, 1.6%. I mean, it's not necessarily perfect, but it's a medium growth rate, will grow to 1,029 million if given 60 years. All right, so that concludes 8C. Stay tuned. Tomorrow we'll probably have the next two, I think 8A and 8B, or 9, sorry, 9A, 9B. Yep, 9A, 9B. All right, have a good night.